Welcome back to this amazing edition of the Voices of Video. So we are in a build up to IBC. It's about T minus 5.5 weeks. Hard to believe. That also means that summer is over and we are coming into the fall, which for some of us in warmer climates is probably very welcomed. But in all seriousness, this is a real exciting time because I get to be joined by our VPU ecosystem partners, and we're holding a whole series of conversations for you, for the listeners, both about what is happening in the ecosystem and then what you will see and the conversations you will have at IBC. So with that, I am joined again, Dominique from Scalstrm. Thank you for being on. Welcome to Voices of Video.
Yeah, glad to be here again. Hi.
And Alexander, I think what we've done 5 or 6 episodes now together. I think across our various shows and channels.
I lost count.
Exactly.
To be here again.
Yeah. Well, it's really great to have you. It's great to have both of you. Dominic, we've also talked multiple times. So we were preparing and brainstorming, I guess, about what we wanted to talk about in this particular interview segment. And I'm really excited about this discussion because the VPU is often we characterize it as the engine. It's the engine of the video encoding workflows, which are, of course, essential. They're paramount to what we all do in terms of operating services, delivering content. But there is a whole software framework around the engine, just like a car. You could have an engine sitting in your garage, but it's not going to be very useful just by itself. And yet it's so essential. Without that engine, and the better the engine is, maybe the faster the car can go, it can use less fuel, all those good things. So I think it's a great analogy. So today we're going to talk about the software around the engine, the software around the VPU. And who wants to start? Because I know both of you had some examples of where, you're involved in discussions, projects, where the software is a really essential component.
I don't mind starting. So I think it's a good topic to discuss because often we forget at the engine. It's important to have a very powerful engine, and this is how we came into contact. More than a year ago? Actually, last year at IBC, I think the first time. And then with the powerful engine, you can be sustainable, and then I do much more on one server. But if you start dig into the details and go into live production systems, there's a lot more around it than the engine itself. And then mainly, from the customer point of view, there are different formats of signals. There may be interruptions into the network. There's a lot of a huge layer behind it, or beyond it. And then this is what we figured out during the year. And then you can use standard tools running on the VPU cards, but it's important to build a whole layer around it. And this is what we've done in the last, last few months, where we built a rock solid system together with the engine. So mainly on resilience, redundancy, features around it, also the flexibility to spin it up with APIs and so on. So I think this initially the performance was the key differentiator, but if you go beyond that, then even with the powerful engine, you can the system make even better with the whole software layer around it, and this is what we're focusing on in the last few months, let's say. So
yeah. Alexander, I know this is what you do as an integrator.
Yeah, we of course we interface with all kinds of hardware cards in very different ways. And when we first learned about the VPUs, it was great to see that they are supporting both the low level interface that we would not touch, because that's one level too low beyond what we usually do. But there was also FFmpeg and GStreamer, so we would have two mainstream open source tools with which we could access these cards. However, as we do most of our media processing based on the Norsk SDK from Ideas, that was our main interface to the card. But we knew all the time we could interfaces with different tools in different ways. So that gave us some leeway around how to approach this. So in the end, we usually for live processing just use the Norsk SDK, which has a lot of advantages for us here. And what we see is that the power itself, the engine itself, is very important, and it's the core of what you can do with these cards. And it's amazing what kind of density we can achieve with that, how powerful they are. But in a way, it's like so it's an ASIC beyond under the hood. And if you look at other fields where you have an ASIC, it's most prominently, for instance, in switches and routers. There you have also ASICs that do the heavy work. But the ASIC there as well is not accessible to you in its raw form. You need something that interfaces with it. And there you have different operating systems on these switches, and you have different tools of software that come all with their pros and cons. So it's important that you have that independent piece of hardware that you can access in different ways. But then for a specific use case, for a specific customer group, you boil it down to something that fulfills their needs completely, where you completely adopt to what they want to do with the system. And so that is where you leave that universal FFmpeg interface and rather build something that is more battle tested, more reliable. And part is also the testing and just seeing this is what the card can do in principle, but this is the subset of use cases that I support and that I have thoroughly tested so that I can testify to the customers. Mm-hmm. If you want to do that workload, we've exactly tested that workload, that works, that is, we can put our guarantee on it. Mm-hmm. That's one part of how to work with such a physical card system. And the other part is there is a lot of functionality that the card covers, but it does not cover all. It's a specialist, and it does what it does very good, but it does not do everything. And there still is part of at least what we have to do in our day-to-day business where we have functionality that is not available on the card. So we have to combine it with software-based or with GPU-based transcoding. So it's good to have these options.
Yeah. So this is a very good point, because one of the challenges that the industry has to grapple with, or an engineer has to grapple with when adopting a VPU, is that fundamentally, as we've just said, what we're bringing, what the VPU is the engine. But, the analogy is, okay, that's great. It's like I happen to have a friend who's actually builds cars, he builds hot rods and so, maybe everyone kind of has that one friend, who actually would love to just take an engine and build a car. But for me, I'm going to have to go out and buy a car. I need one that's already built, that's, done for me, both because I don't have the ability to build one and I don't want to build one, even if I could. So I think a lot of the market is in that same position, right? And more importantly, most workflows that I see, and I'm curious to get your reactions and response, see if it's similar, what they're using today are sort of, you could say generically, complete solutions. So then the challenge is, okay, I want to improve my efficiency and my throughput by 10x. How do I do that? Well, I can do it with VPUs. However, I still need all of the software around that. I often call it the media processing framework, which you could say is the software transcoder. What I'm interested in, and I'm gonna start with you, Alexander, and then let Dominic, share from their perspective, what they see. But I know the projects that you get involved in, and I'm not going to steal your thunder, so I'll let you give some insights. But you have to deal with an incredible diversity of standards and input types and formats, and sometimes very unusual requirements. And people may say, why is that? Well, it doesn't really matter. That's the requirement of the project.
It is, yeah, exactly, and sometimes it feels as if most of us in the industry are part of a very aligned bubble of engineers that talk about a very specific, well-rounded set of tools that you can work with. But if you go outside of that bubble, very quickly,
in the real world, I would say,
in the real world, yes, there is a lot of other stuff that people still want to have and want to see and have to work with. So we work a lot in tenders, as I think Dominique does as well. So what we saw in a tender that we won for the European Parliament, we talked about it before, is something where we have to do deinterlacing. That's the first thing. You wouldn't think deinterlacing necessary in 2025, but still it happens for some or the other reasons. At least it's only in the input, not in the output. That's a good thing. Then we have 32 audio channels, with it also something that is scaling to a lot. If we have 10 channels, that's 320 audio channels. That's a lot of audio transcoding that we have to do. In another project another tender that we have been working on, we got a whole other bunch of combinations that the customer has asked for in the pricing sheet. And this included some weird options where we asked him, do you really think this is necessary? And he said, yes, we have specific customers all over the world where we have gathered this requirements. And for instance, one thing was the customer needs a price for transcoding of an input format, which is UHD 4K input, with AVC H.264 encoding and interlace. And he wants to get UHD and interlace out of that. So that's something that you would only expect, I think, in some 80s retro party where you have a Back to the Future party where you have some 8-bit music on your quantum computer, something weird like that. But it happens in the real life. We see that. And at the same time, we see a request for unpack 2 video codecs, which also are not supported by the VPU card, but are still in practice, and there are still use cases where we have to cover it. So there is some functionality that we have to add either in CPU or in GPU on top of what we do with the VPU card.
So something, and Dominique, I'm going to get to you, but something that probably the listeners are saying, okay, fine, great. So you're using VPUs, you're able to deal with, this matrix of unusual format requests, standards, etc. But how are you doing that? You're running this all on the VPU? I don't think the VPU supports interlace decoding, So why don't you, and actually I'd like both of you to explain your approaches to how you're solving this, because, this is important to understand that you can still be using VPU and yet support standards and formats that are not fundamentally supported on the card.
Oh, correct. And indeed, some parts are, I think the engine as such is a powerful engine and then supports most of the formats, but taking interlaced, that's one thing. I to deinterlace, for example, with the current card, we do this in software, in CPU, for example. So we build a layer around it to deinterlace, and then I handle it from there. And then there are also other formats, and our transcoding solution, it's well integrated with our origin and packager behind it. So in that sense, it's a good thing that we have the flexibility that we can see where it makes most sense to fix certain issues. Some parts we need to fix on the transcoding side, but since we feed the signal anyhow to our origin and packager, sometimes it makes sense to to handle it on the origin as such, because currently our transcoding solution, it's integrated with the origin, and then for now not intended as a standalone live transcoder. For offline, of course, it's a separate case, but for live transcoding, it's kind of integrated solution, and this gives us a real benefit in my opinion, because then you have one end-to-end system and we can handle it from the source till we deliver it. Even we can do the CDN, but let's say we can deliver it to the CDN, and then we will make sure that everything is redundant, resilient, that we handle all the formats. Either we do it in CPU, of course, preferably we do it in the VPU cards as much as possible. But some parts we just take out and handle in CPU, either on the transcoding side or on the origin side. And then I think this is, in the end, a really good ecosystem and a really good architecture as such.
Yeah, and I think we love to work with your products, Dominique. I think it's important also to see that you can operate on a very small footprint. You don't need so much capacity on these machines, and you integrate a lot of these services into small either virtual machines on a cloud provider or on-prem. If you take the contrast to how many people are doing naive cloud installations, they have hundreds of services distributed, and it's so easy to lose track and to underestimate the complexity of following up with all that the streaming in between from one step to the other. So this tendency to not go back in time, but rather to use the amazing capacity that modern hardware has and do a lot of things on a very small footprint is an amazing counterpoint to what you see in some over-bloated cloud setups that we've seen with customers as well.
I love your use of the word, Alexander, naive. Because I think and you guys must be seeing this in your RFPs and the request coming in, but operational cost is under pressure across the board, and it's super fascinating that. In the past, I think operational cost was a little more driven. I will, very generically say by the reality that maybe business was under pressure, revenues were down. In other words, just like in our own personal lives, if I'm not making as much money, I have to cut how much money I'm spending, and so it was more kind of just very practical. Now, what's really fascinating to me, and it's terrible news, when you read about someone like a Microsoft or a Meta laying off literally, sometimes 10,000 employees. But what's super fascinating is these companies are doing it sometimes in the middle of record profits. And it's a head scratcher, right? And, again, I can't even imagine putting myself in a position if I were working at one of those companies and was facing it, the emotion I would feel, like, hang on, you're eliminating my role and thousands of others, and yet we're posting record profits and our stock, has never been higher. So that's a whole nother issue. The point that I'm making, though, is that companies are now mandating that they get fit. It's like this isn't about, hey, we're running out of money, so we literally have to cut our operational budgets. This is, why are we just spending money because that's just how we've always done it, and that is in the context of what I just covered is bad news if you happen to be one of those affected. But for those of us who are providing services and products and solutions and technologies into these organizations, this actually is opening up tremendous opportunities, provided, that the teams are aware of what's going on. And so your description of the naive cloud and where you just have these big bloated systems, well, that certainly drove AWS profits for many, 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 many years. But people are waking up, right? Is that what you're seeing?
I don't want to say that all cloud setups are naive. Not at all. I admire.
Yeah, that's not what we're saying. And thank you for pointing that out. Yeah.
Really sophisticated cloud architectures. Yeah. But I also have seen a lot of bloated stuff that simply try to use all the features that are there and not have in mind that in the end you have to manage it, and things can get pretty complicated pretty quickly, and then they get expensive as well. So that's something that you should avoid, and many people don't, and that's where the cloud setup often is not as ideal as it could be. The other thing is that what you say about companies having to watch their profit and their margins is absolutely right, and that is one of the main drivers that make our customers often ask for on-prem solutions now. There's like a trend back to actually do with capex instead of opex and cloud providers. And the interesting stuff is, I think we're in a way similar with Scalstrm, as the core of the application can operate on software only. That's good. That makes it possible to move to a cloud provider and work wherever you want. But if you have access to infrastructure, or can influence how it is built, or build it yourself, then you can use things like the VPU. And if you go beyond the CPU and operate on a VPU for a certain specific task, video encoding in this case, you can also do the same with other accelerators and cards. And that's how we use it in our day-to-day business, where we build these boxes ourselves. So we use a GPU, we use NVIDIA cards where necessary. So we have several setups where we just use a VPU for video encoding, not the GPU, although it could do it. We reserve the GPU for Whisper live to speech to text transcription. So that's something that we can hand over to these specialized devices. And then we're using specific network cards from Mellanox, where we can outsource the actual TLS encryption that we have to do if we deliver a lot of traffic over these cards. The TLS encryption that you notice if you go to a browser with HTTPS, then you have that encryption that shows you get that there's a certified host name. That encryption takes power, and we'd like to take this off the CPU and offload it to some specialized network card. Those are the things that you can do if you have access to these hardware parts that you do not necessarily have or need or know about in a cloud setup. So you have more options to select the tools that you use to meet the budget that the customer has. And as some nice example, I'm just looking here at a small card that I'm currently working on. I don't know if you can see it. That's a small blade carrier, and it has a Raspberry Pi 4 CPU core CPU on it. And this here is the Quadra card, which comes in the M2's the 1M in the M2's form factor. And this is an interesting project that we do, where we try to squeeze the maximum out of very tiny footprint. The whole card has something like 15 watt for the whole server, and it's just power over Ethernet. So this is a very tiny power part, and this is something that you can only do in hardware. And there are a lot of use cases in the field, on the road, where you need that compute power, but only have very few and not really reliable power. So you need something that does not consume too much energy. That's something, the power of having on-prem infrastructure under your control.
Yeah, thank you for showing that, Alexander. I'm of course aware of some of these very, very interesting and niche applications that you build, but this is for me personally, even though I'm a marketing person, but I started programming when I was 12. And by the way, I do say programming because I'm old enough that I taught myself Pascal, COBOL, Fortran. My first year of computer science, I was learning all of those languages. So it's exciting, to think about these really unique applications. But not only is that exciting, but that's really where the value is transferred. I think one of the things about the cloud is that, it sort of abstracts away in some ways some of the fun. And so it's really cool when you can look at, like you say, a little Raspberry Pi form factor. You put a T1M on an M.2 connector on the board. You power it over Ethernet. I mean, talk about edge. That's about as edge as you can get.
As can be, yeah.
Yeah, exactly. It's really cool.
Yeah.
Well, I think let's bring the conversation back to talk about the role of open source. FFmpeg, there's the FFmpeg project, which obviously everybody knows, works with, probably uses or has used in the past. GStreamer, there's GPack. I mean, there's a number of projects out there, right? How do you, so I want to ask sort of a two-part question and get each of your response. So number one, how are you using, or are you using any of these open source projects in your own solutions? So that's the first part of the question. Are you using? If so, what? And maybe tell us, what you're doing. And then the second is, give some insights into where these projects are quite useful, where something like FFmpeg actually is kind of the best tool. When we talk about building this media processing framework around the engine, and then do you have any insights where it's maybe not the best tool, and maybe there's either a different project, or maybe where, you say, look, we just have to go to commercial solutions because we just can't get the performance throughput, whatever.
Mm-hmm. Yeah. No, I think from our side, and when the company was founded in 2017, everything was built from scratch. So we are not using any open source components or any scripts, or everything is built from scratch in optimized code for video. So this is also where the main differentiator on performance is made, I think. If we go to the VPU cards, also there for live transcoding, I fully use the VPU cards and then use the APIs. So we're not using FFmpeg or any open source components to work with the VPU card. So I use all the APIs to interact with the card and then build a whole software layer around it. So normally we don't use open source. Coming back on the question, where does it make sense? From time to time, we have, in the past, we had some requests for a proof of a concept where a specific format needed to be supported. To give an example, RTMP input, for example. At that time, it could make sense to use an FFmpeg in front of it just to convert specific signals or content or types like that. But normally this is really not the default for us. And then even if we would be using FFmpeg to support a certain use case, we will always make sure that we port it, or that we make sure that on our main software line that we will support it in with own code and not open source. So even if it might be temporarily supported, or if we might use temporary FFmpeg, we will always make sure that we optimize it in our own code and use the APIs to interact with cards. So that's a bit the strategy. And then we've also come across a project where open source components were used, but then there were limitations, and perhaps not FFmpeg as such, but two disadvantages, in my opinion. First, flexibility and time to market. If there is an issue on FFmpeg side or whatever open source component, most likely they will fix it, but it will take time. So we have to report it. It will take a lot of time before the customer can benefit from it. And second, I think as we discussed in the beginning a bit, redundancy, resilience, and then what with input failures. So if you have an input failure, FFmpeg will just interrupt the stream and send it back when the input is there again. Yeah, unfortunately, players don't really like that very, very well. Yeah. So therefore, it's important that you build a layer around it that you can also cover these use cases, which is it's harder with open source. I'm not saying it's undoable, but it's pretty hard, and that's why we try to avoid using open source components as much as possible. And then in our main product lines, you won't find these. But in the past, we have then, for proof of concept, sometimes we used it.
Yeah, on our side, it's a bit different because as a systems integrator, we have to work
correct.
a lot more with what we find and what we are asked for. And so on our side, I would draw some lines. So outside of the core video processing business, we use a lot of open source. We use Linux all the way down, which is one of the biggest open source projects. We use Nginx, which is open source. We are using Postgres, MySQL. So a lot of open source components are an important backbone of what we do. Sometimes we have commercial support for them. Sometimes we have commercial editions, but there is a lot of open source technology under the hood. For the core video processing, we usually draw a line between live and VOD. So for VOD, where always when the input formats are very controlled and defined, and that resonates with what you said, Dominic, with potentially a customer who has issues with very different sources. If the source is controlled and uniform, then you can get a lot of things done with FFmpeg for video on demand transcoding, and a lot of our customers do. And it's difficult often if you don't use DRM or have some fancy stuff that you need to persuade a customer to use something else than FFmpeg because it's already working very well. So that is something where we have the most of what we do with FFmpeg is in the on-demand transcoding world. And they're also with or without NETINT cards. So there is a good overlap. And we have been working with Ivan from Stockholm recently to work on getting the NETINT cards ready to be used from within the SVT and core project. So that's also something that we have been working on for on-demand transcoding. For live transcoding, we simply use FFmpeg in a lab environment where we just have to set up something, where we have to test something, where we have to mimic something that a customer is doing with FFmpeg. But for real production work, we are just using commercial software, and in this case, the SDK from the Norse guys. And one of the biggest reasons for that is we often have special needs that we need to get fulfilled very quickly, and Norse can provide that. So it's really great to see how quickly we can adopt to a certain situation compared with what you would get from open source. And the second thing is telemetry and insight, especially with live transcoding. So many things can go wrong. So many things can build up. There is jitter, there is latency, there is packet loss. All these things matter and have a huge impact on the end quality. And you need to have full transparency on what's going on. And that's something that we cannot really achieve with FFmpeg in the same way that we can get it with other tools, including Norse SDK.
Yeah, it's interesting. And by no means are we trying to say, open source bad or open source good or commercial bad or commercial good. It's, I know we all would agree, what's really paramount, what's really critical is that we use the right tools. And I think,
for the right job.
The right tools for exactly for the job. And, I really appreciate it resonates a lot, the distinction between like a VOD workflow versus a live workflow. And invariably, where systems fall over, and I know you guys see this because we've talked about it, where systems fall over, you get under the hood and you say, well, 90% of the issue is it's the wrong architecture. It was the wrong set of technologies. So it wasn't, but very often looking in from the outside, and, there have been some recent high profile, live stream failures, and people are so quick to, sort of make pronouncements as to what it was. And very often it's sometimes more simple than these, big things, that someone might assume. So
absolutely, but and some other angle on the use of open source that we are often confronted with. So I totally understand if a customer is using open source because they want to save money. It's available for free.
Sure.
In the end, that is not always a fair comparison, because in the end, also for the open source software, somebody has to pay, somebody has to do that work, and
somebody's doing the engineering work.
yeah, somebody is doing that, and
Yeah.
somebody needs to sponsor it, and
Yeah.
it depends if we are looking at Linux, where you have all the huge enterprises like Microsoft and IBM investing in it, or you have smaller tools that are also important, but where there is not that huge enterprise behind it that pays it. And then using these FFmpeg tools just to save money and not giving them anything back, that is like being a scrounger in a way. So it's that is something that I feel is a bit unfair towards the open source community whose tools are then being abused or are used for free, and not honoring that there is some work involved as well.
Yeah. Completely agree there. Well, this is a great discussion, and I know that if this were an actual fireside chat, and we were sitting in some idyllic, beautiful place, and we had a little fire going and had our drink of choice, we would just keep talking and have a wonderful discussion. But I think it'd be interesting to end on this. Maybe each of you can share, call it some insights, call it some integration or migration tips and tricks for someone who's listening, who's saying, okay, I'm on some sort of maybe it's a black box solution, maybe they're using some sort of a hardware, encoder that's been in a rack for many, many, many years, but, they need to modernize. Maybe it's a cloud solution. Maybe it's literally, like an OVP, an online video platform, whatever it is, they want to migrate for better flexibility, lower cost, all of the reasons that we talked about. Alexander, maybe you can start. What are, just share, some of the things that they should be thinking about, maybe some pitfalls that you had to step around that you can help them with. Just give your insights there for those who are thinking about making a migration to VPU, and how they can make it easier on themselves.
Of course. So I think the first part that is very important is that they get their requirements right, that they understand what they really want. And it's easy to mix that with marketing material that you get from other solutions, and you think what I want is AWS media services, but that's not what you want. That's not your requirement. What is your actual requirement? And getting to the core of what the customer really needs and what they want to do is not as easy as it might sound. So the first step really is to make your minds up, what do you really need, and then put a business value to different options, and then make a business decision there. That's also important. It's not, we often talk to technicians and technology experts in companies. They have very specific ideas what they want to see, what they would like to implement, what they have done in the lab, what they have tried themselves in a lab environment. But is it what the business needs in terms of long-term profit or value? That's not always the case. So we often see that the people who have the budget, they depend on the technicians and technology people to define their requirements. And there is sometimes a mismatch. And if it's not cleared in the beginning, it falls on your foot at the end of the project. So I think that's the most important part. Get your requirements right. Get your business value right. What do you want to achieve? Yeah. And that's something that an educated discussion can very quickly identify in the beginning, before you even go to any technical details.
Yeah, I love it. That just really resonates. Is a proof point. For those of us that have worked in, around the industry for a while, especially with some of the very, very large platforms and the hyperscalers and all, each of these companies over time have built incredibly capable, usually a small or even a not so small group of PhDs who are really only looking after, video standards, and they're, into the details of their encoder selection, sometimes even building encoders, or certainly working very, very close, to their partners that they're licensing products from. There's a really interesting trend that I've seen recently over the last maybe year and a half. So, and that is that these groups still exist. It's true. Some companies are downsizing a little bit, or maybe they're reallocating. They're saying, hey, let's move some of those folks to go work in a different part of, of the streaming operation. But the focus of the group has shifted. And yes, they're still involved in standards, and they're still kind of doing a lot of the activities you would expect from an advanced technology and coding team. In other words, a whole group of PhDs, they've dedicated their whole life and career to studying video encoding. But I'm thinking of one company in particular where all of a sudden these PhDs are now a part of building a whole new product for this company that is very important and very strategic. And previously that would have been completely outside of their remit. It's like, hey, our job is to evaluate encoders, stay up to date on latest developments of, AV1, AV2, VVC, LCVC, to run all the benchmarks. Like, that's our job. And the reason that I think this is really significant is that it's an example of where the technologists are getting more aligned to the business. Because in this particular example, I'm thinking of what they are working on is really fundamental to the business, and is going to already is looking to unlock billions of dollars of value and revenue streams. And so it's aligned with the business. And so I think one of the tips that you really hit on there, Alexander, is go back, sort of step back for a moment from the technology discussion and say, what is the business discussion? What's the impact? And then what are the best technology choices to drive that? So I love it.
That's perfect, and I think it rings with Parkinson's law, that the idea that any work expands to fill the amount of time that you allot it for.
Yes,
the same is true for the brain power. If you throw a lot of brain power and PhDs at a problem, they take their time. There is enough to talk about. Is there enough business value to justify that? That's a crucial question.
Yeah. That's great. Well, Dominique, what would you recommend?
No, I agree, and then it's important before, when you start on a project, that you know what the end goal should be, and then of course, for us it's slightly different. Alexander is more into the integration business, and then putting pieces and parts together, and then selecting the right parts. For us, of course, we need to know what the customer's requirements are, and if we can fulfill them or not, and if we need to put it on the roadmap or not. And also the business side, I think it's an important one. And what we see in lately is total cost of ownership becomes way more important on the business side than let's say 2 or 3 years ago. 2 or 3 years ago, decisions were made slightly different. These days, it's total cost of ownership, and then if you can slice down the number of hardware or resources required, if it's on-prem, it's hardware; if it's in the cloud, it's resources. In the end, it's power that you need. And then if you can slice it down on the transcoding side with VPU cards, where you need much less hardware or power, you can slice down the costs there. On the origin, the same. Also there we quite perform, so we can slice down a number of hardware. And then if you then take total cost of ownership, then typically we end up pretty low compared to competitors. And then business is, as Alexander mentioned, an important topic where decisions are made. It's not only the technical; it's of course you need to be able to fulfill the requirements. That's must have for us, of course. And then business wise, we try to be have the lowest total cost of ownership. Software, that's software you can discuss, but the less hardware we need, this will reduce the cost. Power supply, which sustainability these days is also a topic. It goes a bit hand in hand, but still, it's an important topic. Less hardware, less power, more sustainable. So I agree. Yeah.
Amazing. Yeah. Well, thank you for the insights. Gentlemen, as always, this was a wonderful discussion, and I think we'll wrap it up here. I do want to encourage all of the listeners, if you are going to be at IBC, if you're going to be in Amsterdam in September, by the way, beautiful time to be in Amsterdam, so maybe wrap a little vacation around it. If you're going to be there, make sure you come by the VPU ecosystem booth. This is the NETINT booth. It is going to be like a party. There are 8 companies that are going to be there. GNL will be there. Scalstrm will be there. And there's going to be 6 others that you'll be able to, just see what's going on in the ecosystem. Obviously, the NETINT team will be there. We're going to be out in force. Guys, I don't know if you know this. We actually just booked one of those holographic displays. So we're going to have right on the corner a life-size hologram of, it might be me. I don't know. I have to create the video, but those always are attention grabbers, because you walk along but no, it's really going to be great. So, thank you as always for listening. We love our listeners. We appreciate your support. Without you, we'd be just talking to ourselves, which maybe we'd still be doing. but as always, thank you to Voices of Video, to the audience. And with that, be safe, be well, and hopefully we'll see you all in September in Amsterdam.
Definitely.
Thank you very much, and see you at IBC.